Hello, Math 142. Here's an example that I hope you're going to like. Let me Okay, a bicycle has wheels with diameter 672 millimeters. The center of the red reflector is on the front wheel, 84 millimeter from the edge of the tire. If the bicycle is traveling at speed of 1.5 meters per second, find the function for the height of the center of the red reflector at time t seconds. Assume that at t equals 0, reflector is at its lowest height. So let's draw a circle in here for the wheel of the bicycle that we have. And just let's say that the center is somewhere in here. We are told that the reflector is at its lowest, so it must be somewhere here, and it is 84 millimeter from the edge of the tire. Okay. What else are we given? We know that the diameter equals 672 millimeter. That means that the radius of this wheel is half of that, 336 millimeters. So 336 millimeter, and that leaves this area right here, I mean the difference to 252 millimeters. What else are we given? We are given that speed of the bike is 1.5 meter per second. We don't like that because we don't want to have two different units. So let's multiply that by 1,000 and say that speed equals 1,500 millimeter per second. Okay. Well, since the reflector is at its lowest in the beginning at time equals 0, I'm going to use cosine function. And so let's use f as a function of time equals some a cosine of bt plus, I think your textbook called this k. Some textbooks write c, it doesn't matter. Bt plus k. So what is this A? That's amplitude. Okay. And let's say vertical stretch. Go to the next page. B being horizontal. Stretch. Or we can also sometimes compression. And K is vertical shift. Can also call it, and I think, yeah, I'm sure in your textbook refers to as midline. Midline. Okay. Well, I need to just rack my brain and see what information, what do I know that could be helpful. I know that period equals 2 pi over b, and of course I'm hunting for this b. What else do we know? We know that the frequency equals 1 over period. And so, which makes it frequency equals b over 2 pi. And if I multiply both sides of this equation by 2 pi, I will get that b equals 2 pi f. So notice that if I find my frequency, then I can calculate what b is. Let me go to the next page. So far, so good. And here, remembering that the veil and the reflector have the same frequency. So I'm going to use information that was given to me for the veil. I know that the circumference of the veil equals pi times diameter equals pi times 672. So 672 pi is the circumference. And I also noticed that, I remember that frequency equals the speed of the bike that was given to me divided by the circumference. The speed of the bike was 1500 millimeter per second over, we said that circumference is 672 pi. And if I simplify that, I get 125 over 56 pi. If you're concerned with the units, remember that the circumference was millimeter. So if I multiply top and bottom of this by 1 over millimeter and 1 over millimeter, notice that this totally cancels, this, and I'm left with 1 over second, which is hertz. Okay. So 125 over 56 pi is my frequency. But what is my B? Now I can claim that B equals 2 pi times frequency. So 2 pi times 125 over 56 pi. I can cancel pi in here, cancel the 56 with 2, gives me 28. So B equals 125 over 28. Okay, let me go to next page. Y equals, we said that we want to use y equals a cosine of bt plus k. So y equals the amplitude, which is the half of overall height, is 252. So go here, 252. Cosine of B 125 over 28t plus 336 for k. What was k? Was translation from ground. Translation from ground to the center of the wheel. The only thing left here is that remember that in the beginning, the author told us, the author of this problem, that the reflector is at its lowest point. So it's at its lowest point and it's going to keep going up. So I do have a reflection for my graph. So I'm going to go ahead and add a negative in here. So y equals negative 252 cosine of 125t over 28 plus 336. And one baby step here is for me to just rearrange it to make it just a little bit nicer. And you don't have to, but rewrite this as y equals 336 minus 252 cosine of 125 over 28t. And now I kind of like to test uh, my final step right here and see that where is y, where is the height of this reflector. Um, and actually, I like this better if I change this to f of t equals, just to be f of t equals. Where is the y when t is 0? Okay, so f of 0 equals 336 minus, when t is 0, this is 0, cosine of 0 is 1, so minus 252. Okay, and that gives me 2 from 6 is a 4, yep, 84. Yeah, okay, so it is consistent. So my final answer is f of t equals 336 minus 252 cosine of 125 over 28 t. And I hope you like this example. Thank you.